Finally, a Russian jet with a long and legendary history is gearing up for its finest hour. The journey of the Russian military aviation industry spans decades, marked by incredible strides in technology, design, and capability. And now we're about to witness the next evolution, as this fighter jet reaches its zenith with the introduction of a groundbreaking engine. Here we're going to delve into the exceptional sixth-generation jets Russia and other countries are working on, and the highly anticipated engine that will change the game of aerial warfare. We'll break down the technology, the strategy, and what this all means in the grand theater of modern combat. Join us as we explore the Russian $100 billion sixth-generation fighter jet engine that enters mass production in 2024. Earlier in 2023, Vladimir Artyakov, the first deputy general director of Rostec, revealed Russia's ambitious plans to ramp up the production of the Su-57 fighter jet. Artyakov emphasized their commitment to fulfilling their obligations to the Ministry of Defense. Therefore, the year ahead promises a significant boost in production rates for the Su-57 under the guidance of the United Aircraft Corporation, or UAC, as part of a state contract. The Su-57 is presently in the initial stages of serial production, and this production rate is set to increase incrementally. Back in November 2020, sources indicated that the production rate for the Su-57 was slated to grow to 15 aircraft per year. Furthermore, reports from August 2020 by Izvestia suggested that the full production rate would be achieved by 2024. It also appears that Rostec is determined to expedite the production process beyond the original timeline. They are diligently working to fulfill a state contract signed in 2017, which entails the production of 76 Su-57 fighters, intended for 3 regiments comprising 24 aircraft each, along with a flight of 4 aircraft, possibly designated for the Lipetsk Combat Training Center. The stipulated deadline for fulfilling this state contract is 2028. Rostec has a history of expressing confidence in exceeding contractual obligations. As of December 2022, the subsidiary of Rostec, United Aircraft Corporation, had already delivered 10 Su-57 fighters. The current plan outlines the delivery of 22 fighters to Rostec by the end of 2024. Artyakov highlighted that the Su-57 platform is continuously evolving, with efforts focused on enhancing its combat capabilities through the incorporation of cutting-edge technologies, resulting in increased effectiveness. A notable milestone was achieved on October 21, 2022, when a modernized Su-57 stealth fighter successfully completed its maiden flight at the Zhukovsky Flight Test Center near Moscow. This aircraft is equipped with advanced onboard systems, extended functionality, intelligent crew support, and the ability to utilize an extensive array of new weapons. Additionally, testing is underway to install a second-stage engine on the aircraft, further enhancing its performance. The UAC's press service announced that deliveries of Su-57 fighters equipped with second-stage engines would commence as part of the existing contract with the Russian Ministry of Defense. The latest developments in the world of aviation are truly exciting. Aircraft equipped with second-stage engines are currently undergoing flight tests, marking a significant step forward in aviation technology. This milestone is part of the ongoing serial contract, which plans to supply the Su-57 with these new engines. Collaborative efforts from the United Engine Corporation and the United Aircraft Corporation are driving this initiative, as highlighted by Artyakov. What's particularly remarkable is that the Su-57 is designed to seamlessly accommodate both first and second-stage engines. Even with the first-stage engine, the fighter meets the fundamental requirements for a fifth-generation aircraft, a statement made by the first deputy head of Rostec. Originally, the aircraft was envisioned to be powered by an innovative engine known as the Izdaliye Product 30, designed to enable supersonic cruising without relying on fuel-hungry afterburners. However, during the development and testing phases, the aircraft used an interim power plant, the NPO's Saturn Product 117 engine, which is derived from the afterburning turbofans developed for the Su-35. The Izdaliye 30 engine promises to elevate the Su-57's performance significantly. It will enhance thrust and fuel efficiency, and reduce weight and maintenance requirements. A notable feature of this engine is its serrated exhaust nozzle, also known as a chevron nozzle, which brings several advantages. It improves thrust efficiency, stability, maneuverability, and overall performance, all while reducing engine noise. Importantly, serrated exhaust nozzles have the potential to reduce the infrared and radar signatures of the aircraft. This is achieved by altering the temperature distribution and shape of the exhaust plume, making it harder for IR and radar sensors to detect and track the aircraft. The decision by Russia to ramp up the production rate of the Su-57 underscores its impressive performance during trial operations in Ukraine. With the addition of second-stage engines featuring serrated nozzles, the Su-57's rear aspect stealth capabilities will experience a significant enhancement, akin to the F-35. This enhancement will enable the fighter to penetrate Ukrainian airspace more effectively. As Russia continues to expand its inventory of Su-57 fighters and more Russian fighter pilots become operational on these advanced aircraft, the likelihood of increased operational deployment of the Su-57 in Ukraine becomes more plausible. This development is not only significant for the aircraft's performance, but also for its ability to carry cutting-edge, powerful weapons. These include the Product 70 Gremlin hypersonic missile and the Drell glide bomb, highlighting the Su-57's potential to deliver advanced, hard-hitting payloads in contested airspace. Mind you, Russia is not alone in the development and deployment of these sixth-generation fighters. Another remarkable project is the Future Combat Air System, FCAS, which is a collaborative endeavor involving Dassault Aviation, Airbus, Indra Sistemas, and the Thales Group in Europe. FCAS is a comprehensive combat system, incorporating the next-generation weapon system and other airborne assets within the future operational battlefield. This ambitious initiative is set to replace France's Rafales, Germany's Typhoons, and Spain's EF-18 Hornets by the 2040s. The engine for these future fighter jets is being developed by Safran Aircraft Engines, with MTU Aero engines playing a leading role in engine services. The aircraft is expected to be powered by two MTU or Safran afterburning engines, each generating between 20,000 and 30,000 pounds of thrust, aiming for a top speed of 1243 miles per hour or Mach 1.6. A test flight for a demonstrator is anticipated around 2027, with operational deployment expected by 2040. Another exciting venture is the Global Combat Air Program, which combines the BAE Systems Tempest and Mitsubishi FX projects. In Japan, Mitsubishi Heavy Industries leads the way, with support from IHI Corporation for engines and Mitsubishi Electric for electronics. In the UK, BAE Systems is responsible for the aircraft, Rolls-Royce for engines, and Leonardo UK for electronics. Italian companies Leonardo SPA and Avio Aero, along with MBDA, will contribute to the development, particularly in missile technology. Plans for detailed development and cost-sharing arrangements among these companies will be finalized by 2024, with production expected to commence around 2030. The first aircraft is set to enter service in 2035. This aircraft will leverage advanced technologies, including artificial intelligence, machine learning, and autonomous systems, enabling both manned and unmanned flight capabilities. It will harness swarming technology to control drones and gather data from various sources, creating reliable information shared across connected aircraft within a combat cloud. Operating in stealth mode, the aircraft will offer comprehensive battlefield awareness while carrying a substantial payload, including next-generation weaponry such as directed energy weapons and hypersonic missiles. Shifting gears to the FA-XX, this project is dedicated to developing a forthcoming sixth-generation air superiority fighter, intended to replace the United States Navy's aging FA-18 EF Super Hornet. The FA-XX initiative is born out of the realization that the current fleet of FA-18 Super Hornets will reach the end of their 9,000 hours of service life by the early 2030s. The project is set to explore a range of cutting-edge technologies, including comprehensive sensor connectivity and electronically adaptable smart skins. The FA-XX platforms will be engineered to accommodate missile systems, incorporate power and cooling mechanisms for directed energy weapons, and integrate sensors capable of targeting objects with minimal radar cross-sections. Moreover, there's an active exploration into incorporating cyber warfare capabilities at a tactical level, establishing a cohesive family of systems. Preliminary estimates suggest that the FA-XX's speed may be capped at around 1,190 meters per hour, or Mach 1.5. Beyond speed, the aircraft's payload capability, range, weaponry, and equipment are anticipated to at least match, if not surpass, the current Super Hornet's capabilities. A crucial requirement is that it must be capable of operating from both Navy Nimitz-class and Gerald R. Ford-class aircraft carriers. The Next Generation Air Dominance, or NGAD program, undertaken by the United States Air Force, is another noteworthy initiative. It aims to craft a sixth-generation fighter that will ultimately replace the venerable F-22 Raptor. The NGAD project is focused on advancing pivotal technologies across various domains, encompassing propulsion, stealth, sophisticated weaponry, digital design, and efficient thermal management of the aircraft's signature. The NGAD is anticipated to operate at altitudes ranging from 20,000 to 22,000 meters and reach top speeds of approximately Mach 2.8. These capabilities are set to match or exceed the F-22's altitude and speed characteristics. The NGAD's engine, a critical component, is still undergoing development. Two engines, GE Aviation's XA-100 and Pratt & AMP, Whitney's XA-101, are currently in the testing phase, with durability and other assessments planned over the next 2 years. China's prospective sixth-generation stealth fighter, known as J-28, has also been revealed through concept art shared on social media by its military aviation industry. Although these designs are in their early stages and subject to change, a notable trend is evident. China's upcoming sixth-generation stealth aircraft is likely to feature a tailless design, similar to America's next-generation air dominance stealth fighter. As for the specific specifications of the J-28, they remain classified, shrouding its features in mystery. Currently, there are no reports disclosing information about its sensors, avionics, weapon systems, speed, or engine characteristics. Beyond the Sukhoi Su-57, Mikoyan is actively involved in the development of the Mikoyan MiG-41-2. This fighter is also known as PKDP, a next-generation Russian stealth interceptor aircraft and heavy fighter. The aircraft is positioned to replace the Mikoyan MiG-31 in the Russian Air Force by the mid-2030s. One of the standout features of the MiG-41 is its ability to operate stealthily. The design of the aircraft is anticipated to enable cruising speeds exceeding Mach 3, or approximately 2,300 miles per hour, allowing for rapid coverage of Russia's vast territory in minimal time. These developments are a testament to the ever-advancing and competitive landscape of sixth-generation fighter jets in modern aerial warfare. Interestingly, the journey toward the creation of the remarkable Su-57 is a saga that traces its roots back to 1979, when the Soviet Union recognized the need for a next-generation fighter aircraft. This vision aimed to see a new fighter grace the skies by the 1990s. The path to this goal began with the launch of the I-90 program in the 1980s. The objective was to develop a multi-role fighter with substantial ground attack capabilities that would ultimately replace the MiG-29 and Su-27, the frontline tactical aviation workhorses of the time. The responsibility to craft the Su-57 fell into the capable hands of the Russian company Mikoyan, which embarked on the development of a MiG-144 aircraft, better known as 1.44 RTM. That's the same company now working on the MiG-41. Then, Mikoyan's approach was marked by a philosophy of quantity over quality, a simple idea that had far-reaching implications. However, the story doesn't end there. Amidst the pursuit of this multi-role fighter dream, the light fighter program faced obstacles, ultimately unraveling. But Sukhoi, another Soviet company, wasn't ready to let the vision fade. They undertook the responsibility and began delving into the technologies needed for a next-generation fighter. Thus, the Su-37, later evolving into the Su-47, was born. This phase of the journey was characterized by the relentless pursuit of quality over quantity. Pavel Sukhoi, the visionary behind the company, was instrumental in fostering this philosophy. The Su-47, an experimental supersonic fighter jet, became the embodiment of cutting-edge technology and innovation. Fast forward to the late 1990s when the Russian Ministry of Defense launched a new fighter jet development program known as the PAK-FA, or Prospective Aeronautical Complex Frontline Air Forces. This program aimed to create a stealth fighter jet that would serve as the foundation for a family of stealth combat aircraft. The Su-57, which emerged from this program, was designed to be versatile and significantly smaller than its predecessors. Unfortunately, as the Su-57 entered the production phase, a litany of challenges arose. Delays became a recurring theme, prompting some to liken the development process to that of the Firefly aircraft. The original maiden flight of the Su-57 was scheduled for around 2007, but didn't come to fruition until 2010. Despite finally achieving supersonic flight in 2011, the aircraft faced structural issues. The 5 original prototypes revealed structural cracks resulting from inadequate fatigue life, while engine problems posed further setbacks. Nonetheless, the Su-57 program persevered, and in 2020, the Russian Aerospace Forces finally received their first delivery of Su-57S. This marked a significant milestone, and it wasn't the end of the story. The next step to this aircraft advancement is its new jet engine that will soon be mass-produced, the Izdaliye 30 engine. The MiG-41 is also considering using a variant of the Izdaliye 30 engine that is currently in the works for the Su-57 as its power source. Ilya Tarasenko, the Director General of RSK MiG, shared his thoughts on the MiG-41's potential during an RT interview. He envisions the MiG-41 as a groundbreaking creation with the capability to reach remarkable speeds, possibly ranging between Mach 4 and 4.3. The MiG-41 speed is just one facet of its prowess. It's also being considered to be equipped with an anti-missile laser system, a feature that would significantly bolster the aircraft's defensive capabilities. The strategic objective of the PAK-DP, the MiG-41's development project, extends to intercepting hypersonic missiles, and this goal is to be achieved through the integration of a multifunctional long-range interceptor missile system. The system is designed to release multiple sub-missiles, increasing the likelihood of successfully intercepting hypersonic threats. Furthermore, the PAK-DP's versatility is underscored by its potential to carry anti-satellite missiles, making it a versatile solution to various modern threats. The speculated laser weapons on the MiG-41 are anticipated to deliver a high degree of accuracy and precision, making it possible to target specific components of an enemy's aircraft without causing unnecessary collateral damage to surrounding areas. This precision becomes especially vital in urban or populated areas where minimizing collateral damage is crucial. In addition to precision, these laser weapons also offer stealth advantages. They emit no visible trail and work silently, making them ideal for covert operations. Furthermore, they can be employed to disable enemy radar systems, providing a significant tactical advantage in combat scenarios. Stealth capabilities are central to the design of the MiG-41. The aircraft is rumored to incorporate advanced stealth technologies in both its structure and materials, with the goal of minimizing its radar cross-section. This design approach makes it difficult to detect by radar. Active stealth, a feature that involves using onboard systems to detect and evade radar and other detection systems, is expected. Additionally, adaptive camouflage technology is likely to be employed, which utilizes a combination of sensors, cameras, and displays to create a dynamic invisibility cloak. This feature can change the aircraft's appearance to blend seamlessly with its surroundings. Advanced avionics are another integral feature of sixth-generation fighters. The MiG-41 is expected to feature artificial intelligence systems that enhance situational awareness and decision-making capabilities. AI can automate various functions, such as target acquisition and threat detection, allowing the pilot to focus on higher-level tasks. Hyperspectral imaging technology is also anticipated, using a range of sensors to capture detailed information about the aircraft's surroundings, which enhances situational awareness. Advanced communication systems, including quantum communication or satellite communication, will allow the MiG-41 to communicate securely and efficiently with other aircraft and ground-based systems. Sensor fusion capabilities will enable the integration of data from multiple sensors, creating a more accurate and comprehensive picture of the aircraft's surroundings. This enhances the aircraft's ability to detect and respond to threats quickly and effectively. Furthermore, the MiG-41 is envisioned to become an interceptor for hypersonic missiles, equipped with a multifunctional long-range interceptor missile system. This system will enable the aircraft to engage targets from a safe distance, reducing the risk of detection by enemy aircraft or air defense systems. The missile system can offer multiple targeting options, including infrared, radar, and optical sensors, providing the pilot with a range of options based on the specific mission and target type. This not only enhances mission flexibility, but also allows the MiG-41 to adapt to changing mission requirements. Despite these exciting speculations, it's essential to note that these capabilities are not officially confirmed, and concrete details about the aircraft are still pending. However, we must admit that Russia has greatly improved its aircraft engineering. Just like the MiG-41, we are aware the Su-57 boasts impressive capabilities, despite its prolonged development phase. It's known for its remarkable agility, with some even suggesting it surpasses the F-35 in maneuverability. Recent reports from the United Kingdom's Ministry of Defense Intelligence have even stirred speculation about the deployment of the Russian fighter in the conflict with Ukraine. While the extent of this involvement remains shrouded in uncertainty, it sparks intriguing questions about the capabilities and strategic considerations surrounding this advanced fighter jet. However, Russia has laid apparent emphasis on avoiding reputational damage associated with potential Su-57 losses. This could mean they have refrained from deploying the Su-57 beyond Russian airspace. With its advanced capabilities, the aircraft is well equipped for a standoff role, allowing it to launch long-range air-to-air missiles from beyond the reach of enemy air defenses. This standoff capability eliminates the need for close-quarters combat, making use of the Su-57's distinctive advantages. It's a pragmatic decision, as losing one of these cutting-edge jets, which Russia has in relatively limited numbers, would have both strategic and economic consequences. Even with its impressive capabilities, the Su-57 will still see better days once its new and powerful Izdaliya-30 engine gets launched. Thanks for watching. While you're still here, click on the link appearing on your screen to check out another of our interesting videos. See you there.